All right, so we are going to look at the two different forms of a parabola. We have standard or general form, which looks like this. F of x equals ax squared plus bx plus c. For it to be a quadratic, you have to have a squared in there, and that just puts the terms in descending order. So you have the x squared term, then just an x, and then c is the constant, that's just the number. Vertex form is the form that where you can tell what the vertex is. Okay, so it's still going to be f of x equals. You'll have this coefficient out front, so it's a. And again, when we write out like the general format of something, like there's not numbers in it. Once we do an actual problem and there's values in there, it'll make more sense. So we have some sort of coefficient out front, x minus h squared plus k. I feel like in one of my classes, it might have been here or the other one, somebody mentioned like the h and the k something. Did you see that format last year in Algebra 2? Yeah. Or maybe some of you did. I don't know. I had somebody bring up the h and the k thing. They were like, oh, is that this? And so I think you may have seen it, whether you remember or not. All right, so the vertex is h comma k. Because if you think about how this got shifted, it went right h up k. That's where the center is. So the center is h comma k. That's our vertex. And then we have something called the axis of symmetry, which is the vertical line that cuts the parabola in half. And that will be at the same place at h. So it'll be x equals h. The reason it's x equals is it's a vertical line, hoi vux. Let me draw you a picture. If you don't want to draw it, that's fine, but let me just show you because a visual helps. Here's a parabola. This would be the vertex, h comma k, and then this is the axis of symmetry. Do you see what I'm saying there? Symmetry cuts it in half. Yes, thank you. Thank you for heads nodding. All right. So we're going to practice going back and forth between those two forms. So from general to vertex form and from vertex form to general form, just being able to go back and forth. So it says, write these in standard or general form. These are not difficult. They are just a little bit of work, but you guys seem to like the algebra steps better than the graphing. So I think this is going to go okay. Do you see how it's x plus 8 squared? That means you're going to write that twice. So write the x plus 8 times x plus 8. It's just going to be a little bit of writing. It's not like necessarily difficult, but you just have to make sure that you write it out. Right, and so I call this FOIL, first, outside, inside, last. If you don't want to call it that, that's totally fine. You're basically just doing a lot of distributing. All right, ready? X times x. Very good. You are also smart. All right. Now the outsides will be 8x. The insides will be 8x. Like if you multiply these, you get 8x. If you multiply these, you get 8x. So what is that all together? Good. 16x. And then 8 times 8, 64 minus 3. Okay, so 64 minus 3 would be 61. So it's just a lot of like distributing. You're just multiplying stuff together, but it sounds like you guys can multiply, so you're going to be just fine. The only thing I'll say is people try to do this in their head and mess it up. You have to actually write it down. Okay, so you just can't be scared of doing a little bit of work is all. So for this one, and you can't lose that f of x equals, otherwise it's not an equation anymore. So now we've got that 2 out front. Go ahead and write the x minus 4 twice. It's about like staying organized more than anything else. I know people that are like absolute geniuses and can't get through math problems because they just like they write things everywhere. It's just about staying organized. So now we're going to do the exact same thing, except we've got a 2 out front. So that 2 is going to just have to like wait its turn. And we're going to do FOIL. First, x times x, x squared. Oh my gosh, there's a squared because it's a quadratic. The outsides would be minus 4x, and the insides would be minus 4x. So negative, good, negative 8x. Like you owe someone $4, and then you owe them another $4. Now you owe them $8. And then negative 4 times negative 4 is positive 16. Close your parenthesis, minus 7. Now, this one had a 2 out front, so what do we have to do with the 2? Distribute. So there's just like one extra step there. So distribute the 2. 2x squared minus 16x. And then it would be plus what? 2 times 16 be 32 minus 7. Count on your fingers if you need to. 32 minus 7 be 25. $25, $26, $27, $28, $29, $30, 31, $32. All right, let's try this one. It's going to be the exact same thing. Leave that -3 out front. It's just going to have to wait patiently. Write the x minus 1 twice. I call it a twin. There's two of them. And then you're going to do FOIL. So first outside, inside, last. Or again, if you don't want to call it that, you don't have to. But leave that -3 alone. Like there's going to be another step to this problem. You can't do it all at once. And if we multiply this out, we will get x squared. And then what will the next part be? Yeah, the outsides will be -1x, insides will be -1x. So together, -2x, -1 times -1 is 1. Good. Yeah, again, you just like pep talk. I just keep giving pep talks. You got to write it down. You got to write it down. Just don't try to do it in your head. All right, and then we're going to distribute a -3. So that will be -3x squared. And then what? Plus 6x. And then it would be -3, but then plus 5. So -3 plus 5 plus 2. Good. Well, you're going to see 1s, 2s, 3s, 4s, and 5s a lot because when stuff is non-calculator, I give you little numbers. Do you feel okay with that? Okay. Just multiplying things together. Because we're about to ready to do that backwards and it's a little harder backwards. Okay. So we're going to factor these quadratics. In fact, I'm actually going to hit pause and ask you to try these with the person next to you. So let's see how this went. How would you split up an x squared? What would you put in each parenthesis? X times x gives you x squared. Instead of multiplying it together, you're splitting it apart is what you're doing. Now, how would you split 16? 4 times 4. And then what do you need? What symbols, pluses and minuses, to get a positive 8x in the middle? Plus, if you were to do FOIL to this, first outside, inside, last, like we just did, you would get what we just started. We did FOIL in reverse. We unfoiled. We lie off. I don't know. Now, do you notice how they're the exact same thing? Because this is the big takeaway. Do you see how it's a twin? So how should we write our answer? X plus 4 squared. Good. Go ahead and flip forward. We're facing forward now. All right, this one. Again, it would be x times x. And then how would you split up 36? Good. Why are they both negative? -6 and -6 gives you -12. So you would want to write it as x minus 6 squared. It is a twin. So good. This one will be x and x, 5 and 5. And then what? Now, if one, let's talk about that. If one was plus and one was minus, they would cancel out and you'd have nothing in the middle. So that won't work. They have to both be the same in this case. Good. Perfect. And so it'll be x minus 5 squared. So what I want you to try with the next 3, and again, you can just turn to the person next to you. I want you to figure out what number goes on that blank to force it to be a twin. And then I want you to write it as whatever squared. Okay? Figure out what goes on that line to make it work out and then write it as something squared. So, hey guys, what did you put on the line for this one? 9. And then in the parentheses, you would put x plus 3. 3 plus 3 is 6. 3 squared is 9. Magical. Okay, what goes on this line? 49. And in here, it'll be x. Good. Do you see how this symbol just matches whatever there is there? Like if it's subtraction, it's subtraction. If it's addition, it's addition. Don't change it. 7 and 7 makes 14. They're negative, so it's negative. 7 squared is 49. This one's a little bit tricky. Does anyone think they got this one?
It's also, yeah, it's number 3.
Oh, was there one like that before?
It's the exact
Same one? Oh, there we go. See, use what's on the paper already. And then what goes in here? X minus 1. -1 and -1 gives you -2. -1 squared is 1. Don't forget about 1. People forget about 1 all the time. Now, what do you notice about these 3 numbers? 9, 49, and 1.
They're odd.
They happen to all be odd. Oh, what? Yeah, we can square root them. What do we call numbers that you can square root? They're all perfect squares. What are some other perfect squares? 36, 81, 16, 121, 144. Okay, so listen, whatever number goes there, it's gonna be a perfect square and it's going to be added. They will always be added. Do you see how they're always plus? That's because when you square something, it is. Okay, so to complete the square, here's what you guys did. You did this without me even having to explain it to you because you're all brilliant. How do you get from 6 to 9? And from 14 to 49, like how do you get from there to there? You take the middle number and you divide it by, divide by 2. And I heard someone say the other step, divide by 2 and square. You divide by 2 and square. You take that middle coefficient, divide it by 2 and square it. That is how you complete the square. But you did it without me having to say that because it's just number sense, which you guys have. Okay. We'll do a couple of these and then I'll give you a break. All right. So first thing that we're going to do is whatever this third number is, you want to move it to the other side because if you notice 8 is not a perfect square and it's not the number that we want. So watch how I write this. I'm going to leave a little blank and move that 8 to the other side. I just subtracted it to the other side. Now it's exactly like what we just did. I left a blank. We want to figure out what goes on the blank to complete the square. And you don't have to use another color, but I will just to illustrate what we're doing. What are we going to add? It is not 16. It is 4. You want it, 4 is a little bit weird. You want to take this number, divide it by 2 and square. So it's 4 divided by 2. It's 2 and then 2 squared. That one's a little weird because 2 plus 2 is 4 and 2 squared is 4. 4 is a cool number. But anyway, if you add that to the left side, you have to add it to the right side. So just make sure you add it to both sides of the equation. And then we want to write this as a twin. We want to write it as something squared. So what would go in that blank? There will be a 2, but also x plus 2 squared equals, and then what would this give us? -4. That's it. Is that slight? That's what we're saying. So let's try number 11. Write out the first 2 terms, leave a blank, subtract that 1 to the other side. And again, you don't have to use another color. I'm just going to, colors don't show up very well on this projector anyway. What are we going to add to both sides? 9. Good. Add 9 to both sides. And you're going to write it as something squared, blank squared. X plus 3. Beautiful. Equals 8. Good. I'm just going to give you one to try. I'm just going to give you a little problem down here. I want you guys to try. I'm going to give you a break before we do number 12. Thank you. All right. I'm going to hit pause. I want you guys to just try that one with the person next to you, and then I'll give you the answer. You can do it. Okay, so let's see what you guys got. We're going to subtract the, hey guys, I want you to check your answer. We're going to subtract the 7 over. What did you guys add to both sides? 25. Awesome. You guys are brilliant. And then it will be something squared because it's a twin. What will go in the blank there? X minus 5. Good. Equals. And then over here, -7. Oh, so 25 minus 7 will be 18. That's it. All right, we will do a 3-minute mobile device break and then we'll do the other half of these notes. All right, so pep talk before we do the next one. This is your pep talk. It is the exact same process, but the numbers are just gonna get a little bit more difficult, but you're not gonna do anything different. And I'm gonna just do the hand holding and pep talking to get you through it, okay? So looking at this next one, first thing you would wanna do is subtract that 3 over. So leave a little blank. Put equals -3, and we're going to figure out what to add to both sides. The reason this one is a little tougher is, let me ask you, why would this one be a little tougher? It's not going to divide by 2 really nicely. So here's what you're going to do is off to the side, I'm going to take the 7 and see our instructions right here, divide by 2 and square. Watch me do this. I'm going to divide it by 2. I just put it over 2 and I'm going to square it. That's it. Just write that off to the side. It's a little note to self. Note to self. All right. I took that middle coefficient. I'm going to divide it by 2 and square. Now here's what we're going to add. And I'll use my green pen here. Here's what we're gonna add to both sides. Hey, kiddos, what is 7 squared? 49, and do you notice that's a perfect square? Oh my gosh. Over, and then 2 squared is 4. So you're gonna add 49/4 to both sides. No panicking, no getting upset. 49/4 is a great number, don't discriminate. It's fine, it's just another number, it's nothing to worry about, okay? Nothing to worry about. We squared 7 and we squared 2, that's literally it. Now you're gonna write it as something squared. It's gonna be the number that we wrote off to the side, okay? X plus 7/2. It is just, it's just the number you wrote off to the side, that's it. Now over here, we are gonna have to kind of like fight our way through that. When you add and subtract fractions, you need a common, which will be 4. So I need to write this as fourths. $1 million question, how many fourths? There we go, 12. Only it's gonna be -12 because there's a negative, okay? So 12 divided by 4 is 3. I just wrote it as 12. There's a negative, so I put the negative in there. Or 3 times 4 is 12 is the other way you could think of that. But the reason I did that is because now we can put them together. This side's not going to change. Over here, it's still going to be fourths. -12. Thank you. I am smart. You know, no one ever really compliments the teacher that they did a nice job on the problem because it's just expected that I know how to do everything. That was really sweet, right? It is my job. Thanks. -12 plus 49, or 49 minus 12, if you will, would be 37. So listen, when you end up with, somebody said 37 before I even got to the end of the problem. That was brilliant. Nice job. Nice job. Listen, you will have halves and fourths. Halves and fourths. That's the only numbers it can be because you're going to divide by 2, that's halves, and then square it, that's fourths. Halves and fourths. If you get fifths or sevenths or sixths, you have done goofed. Do you understand what I'm saying? If you don't know what to do, make up something that's halves and fourths because it's likely that you'll be okay. Let's try again. So for this one, leave yourself a blank and subtract over the 2. Now I realize it's negative, but I don't usually worry about the negative because when you square something, it will always be positive. So I generally don't worry about that. Off to the side, note to self, you're going to take the 3, divide it by 2, and square it. If you can hold that in your head, that's awesome. I just always write it down because I feel like I'm going to forget if I don't. And now we're just going to square those things. So hey guys, 3 squared. 9, and then 2 squared is 4. So you're going to add 9/4 to both sides. Okay, I'm sorry. 3 squared is 9. 2 squared is 4.
Wait, do you subtract that or add it?
We always add because when you square something, it's always positive. So it should always be added. That is a good question. Now you're going to write it as something squared. Remember, it's going to be the number that's off to the side. X minus 3/2. And then the other part you do have to fight through a little bit because you need a common denominator. So how would I write this -2 as fourths? -8/4. Good. You can think of it as 2 times 4 is 8, or 8 divided by 4 is 2, however your brain wants to do that. But then here's your final answer. It'll be x minus 3/2 squared equals how many fourths? 1. -8 plus 9 is 1. You survive. You're going to be okay. All right, now these last ones don't have fractions in. You're welcome. These ones instead have a coefficient out front. So listen, here's how you deal with that. You have to factor out the coefficient, but only from the first 2 terms, because this one you're going to subtract to the other side anyway. In fact, let's just go ahead and do that first. Subtract over that 241. Get rid of it. Bye-bye. So we're going to factor the 3 out of just these 2 terms. That would give you x squared plus, right, 54 divided by 3 was like me, 18 x. I'm factoring the 3 out. Oh, I get what you're saying. No, that's a good question. You do not want to factor out the variable because if you take out an x, it won't be an x squared anymore, and we need it to be a quadratic. I get what you're saying. All right, I'm going to use my green pen here. We want to divide by 2 and square. This one's not a fraction. You just want to take 18, divide it by 2. What do you get? 9 squared, 81. Now here's the only thing. You're not going to do plus 81 on this side because it's not actually an 81. It's a 3 times 81. I know. 3 times 81. Well, 3 times 8 is 24. So do you see why I made it a negative 241? I did that on purpose. Yeah, I was just thinking. So it's going to be 3 times something squared. You want to figure out what to put in the blank. So what's going to go in the blank? X plus 9 equals, yeah, 2. Perfect. I wrote a little too big. I got in the way of the next one. I'm sorry. But okay, good. We're all on the same boat. I'm going to just start down here. So you're going to add that 1 to the other side. Actually, since I wrote too big on that one, let me leave myself more room here. So add that 1 to the other side, and you're going to factor a 2 out of these first 2 terms. So if you factor out a 2, you'd be left with x squared minus 14x. Good. And then there's not going to be a fraction. You're going to divide by 2 and square. So 14 divided by 2 is 7. Squared is 49. But you're not going to add 49 to the other side because it's not a 49. It's a 2 times 49, which would be 98. I usually do 50 times 2 in my head and then like backtrack a little. Yeah. And then here's your final answer. 2 times some. Do you see how I always write it as blank squared? Do that. Like set up the framework or like the skeleton of the problem and then go and fill it in. What will go in this blank? Yeah, x minus 7. I'm very, very sorry. All right, so the whole point, you're probably like, why on earth are we doing this? The whole point of being able to complete the squares, it makes stuff easier for you to graph. If I said here, graph this, how would you do that? Well, you'd probably make a chart and be like, well, let me plug in 1, plug in 2, plug in 3, plug in 4 until you figure out enough points that it looks like a parabola. But if you get it into vertex form, then you can see what the transformations are. So that's kind of the whole point. All right, so we are going to write, well, you have to put f of x equals because it's a function now, right? X squared plus 6x, and then I'll use my other color here. Divide by 2 and square. What would we want to add on? 9. Now, you may have noticed that there's not a 9 there, it's an 8. Do you see that? Oh, divide by 2 and square. Well, see, now I'm going to deal with the 8 because unfortunately, you're not allowed to just go changing the problem. Okay, so I have to turn the 9 back into an 8. And I would do that by subtracting 1. Now, here's my suggestion. Give this part a hug. Give that a hug. Right? You're squeezing tight. Okay, so you want to write it as something squared minus 1. And again, write out that framework and then just go back and fill it in. What's going to go in that blank? X plus 3. Now, that is your vertex form. Please listen to me because every year when I hand out this test, it says, put the quadratic in vertex form. And half the class comes up to me going, what does that mean? That, what we just did. Complete the square. Okay, now I can ask you, how did this shift? What directions did it move? Left 3, down 1. So on your graph here, go left 3, down 1. That is the vertex. -3, -1. Now I need some points on either side. Shh, we're almost done, guys. I need some points on either side, and it's going to be a buy one, get one deal because of symmetry, okay? So if we're centered here at -3, pick a number next to -3 for us to plug in, like -2, good. Now, I usually get asked, do you plug it into the original one or the one that we like changed? It doesn't make a difference, but if you use the one we changed, it's going to be a lot easier. That's why we changed it. -2 plus 3. 1 squared is 1, -1 0. So you get negative 2, 0, same point on the other side. Here is your parabola. Cute, it is cute. And then we're gonna dot in the axis of symmetry. Or I guess you don't have to, I just usually do so that you can see it. Do you see it? Okay. If I don't dot it in, it's invisible. And so that axis of symmetry is x equals negative 3. We did it. We're just gonna try it a couple more times to make sure you've got it, and then we're gonna be done. It is always x equals, it is the Vux part of Hoivux. Yeah, whatever the x is, these match. So whatever you get here, that also goes here. It's the same number. Wait, are you sure? Okay. Looking at the next one, do you see that negative that's out front?
Yeah.
You're going to have to factor that out. It's a negative 1. So we're going to factor that out, but only from the first 2 terms. Do you remember how that third term, we got rid of it anyway? Okay, only from the first 2. So if you factor out that negative, what is that going to give you? X squared minus 8x. Now I'm going to pick up my other color. This is where you complete the square. You need to take 8, divide it by 2, and square it. Good, 16. Now look. I'm glad you're all awake, but now we're unfocused. I need you to come back together here because negatives are tricky. It's not actually a 16, it's a negative 16. You need to turn a negative 16 back into a negative 12. You know how up here we turned the 9 back into the 8? You have to figure out what you're going to adjust. So how do you turn a negative 16 back into a negative 12? You add 4. Good job. Perfect. I just need to make sure everybody's with me. And then your answer here for your vertex form, it'll be negative, write a blank squared plus 4. Again, just set up the framework. And then go back and decide what's going to go in there. It'll be x minus 4. And the whole point of doing that is now you can see the transformations. It makes it easier to graph. Wait, question? All right, it went what directions? Right 4 and up 4. Question there? Did you have a question? I saw your hand go up. So what is our vertex? Yeah, 4, 4. And I would like at least one more point. So what would be good to plug in? Yeah, either 3 or 5. It won't make a difference, actually. They're going to come out to the same thing. I'm just going to plug in 5. 5 minus 4. 1 squared is 1, but it's negative 1 plus 4 would be 3. Good. So you get 5, 3, and then symmetry on the other side. Oh my gosh, why is this one upside down? Negative, reflected over the x-axis. And you can dot in the axis of symmetry if you want. I just did it so you can see it. It'll be x equals 4. That one was kind of nice that it was 4, 4 because you can't mix them up. They're the same number. All right, we're going to try one more. Do you see this 2 out front? Don't fade out on me. I want to make sure you can do this. You're going to factor that out, but only to the first 2. Thank you. It doesn't go into 19 anyway. Whatever that last number is, can you guys please stop talking while talking? Whatever that last number is, you're really not worried about it because you're going to just change it anyhow. All right, so here's the most common mistake I get with this. I'm telling you that a third of you will do this on the test. I could say it all day long. Just let it not be you. People will write this. They'll put that 2 correctly, and then they'll write this. Don't write that. Why is that wrong? You didn't take it out of the 12. I don't know why that happens. I don't know if people are rushing or what, but 12 divided by 2 is 6. Okay, and then to complete the square, we will add. Do you guys feel like you're adding the same stuff over and over and over again? Because I can only give you small numbers without a calculator. So I use the same numbers over and over and over again. Now it's not really a 9. It's really a 2 times 9. It's really an 18. I need to do a plus 1 to turn it back into 19. $18 plus 1 is 19. So write out the framework of it. It's 2 times something squared. Just leave a blank. I feel like the big problem with math is people get stressed. Try to just like do one thing at a time because it does look overwhelming. I would agree with you. And then go back. What goes in the blank? X minus 3. And the whole point is now you can see the transformations. That's the whole point. How did this shift? Good. Right 3, up 1. I'm going to put that point. So 3, 1 is your vertex. And it's going to go up like this, but I'd like at least another point. Okay, so let's plug in 4 because it's next to 3. If we're centered at 3, plug in 4. 4 minus 3, 1. Squared, 1 times 2 is 2, plus 1 is 3. So you get 4, 3. Same on the other side. Oh my gosh, this one's narrower. Why is that? Yes, stretched by 2. You guys are so smart. And your axis of symmetry, but it's x equals 3. I know that sounds like I'm being hateful, but you have to put the x equals.